Welcome, grade 9s, you wonderful people. Welcome to this Worksheet Cloud grade 9 math lesson where we take a look at graphs. I'm Mr. T, your math teacher for today. If you ever wonder why I look like I'm laughing at the start of a video, it's normally because I'm laughing. Invariably, whenever I start filming, I trip over my words at the start of the video and have to restart it 4 or 5 times before I'm actually comfortable and saying the right thing. I'm just going blah, blah, blah. Right. I'm having fun, and at Worksheet Club we are about having fun, which is why we've instituted that rewards hub where you can earn cool rewards while you're learning. Things like Nomu hot chocolate, some fresh merchandise from Worksheet Cloud, or who knows, possibly even that PlayStation 5. I see it pictured there in the middle where it says, "You've earned a reward." If only that were me. Then I would not be here. I would be off playing. No, that's not true. I would still be working. Anyway, enough meandering with my thought. Let's get on to the maths for today. Right, graphs. We have to do them. Fortunately, the graphs that we're doing are actually straight line graphs, which are the simplest of the simplest when it comes to algebraic equations. Not nearly as complicated as the trinomials that we were looking at, which actually are also graphs, but they're bendy graphs called parabolas. But we're not looking at that today. So, lesson goals, basically both ways. Be able to draw a graph if you're given an equation, and be able to find the equation if you're given a graph. Okay. Prior knowledge that will really make a difference if you know it when it comes to this lesson. In fact, I would suggest that if you're not familiar with these things, you go back and take a look at them and then come back to the lesson. Or I suppose you can watch the lesson and see how much you understand, but possibly go off and then come back and do the lesson again when you're more familiar. But yeah, you need to know what the Cartesian plane is and understand XY coordinates. It's basic graph stuff, but yeah, I'll run over it briefly. Okay, here's the Cartesian plane. That's the graph space. Quite often when we are doing graphs, especially like when you're doing data handling, you only work in this quadrant. So you've got just those 2 lines. It's actually part of the same thing, but when you're looking at data handling, you're pretty much looking at positive numbers, which is why you work in this quadrant here, the first quadrant. So this is where your coordinates are both positive. Coordinates are always listed like this. It's in a bracket. It's separated by a semicolon, and it's always XY. So the easiest thing to do is just to remember that X comes before Y in the alphabet, and so the first one is always X. One thing I have seen confuse people is forgetting which is the x-axis and which is the y. One of my students gave me a very silly thing, but I used it. I don't know if I used it, I already knew, but it kind of got stuck in my head. Maybe it's a little naughty, but here we go. X, as in triple X, would be to do with lying down. Don't tell your parents or your teacher I said that. And Y is the other one. So I always remember X is the flat one, and Y is the one that's up and down. All right, so in the first quadrant, we've got a positive X, which means if we read off here, so I'll let our numbers go up from here. So let's say that was 1, that was 2, that was 3. This is 0, so we're in a positive X value. And this is 0, but this is 1, 2, and 3 as we go up, and minus numbers when we go down. So our Y value is a positive. So if I was looking at this point here, I would read my Y value from here and my X value from here. So what is the X value? Does the X line say at this particular point? And what does the Y line say at that particular point? Okay, in this quadrant, your X value is negative. That is because these are negative X values along here. So if I read that value here, it's going to be a minus number. And Y is positive because it's still above the axis. So this is the positive Y numbers. Moving into the third quadrant, we're negative, negative. All right, so this is a case where the x value is still negative, same as it is up there. And our y value is now below the line and also negative. And our last quadrant, our x value is still positive, and our y value is negative. All right, as long as you remember you read it off the axis, you should be fine. So here is the generalized formula for a straight line graph. It's y equals mx plus c, where m means the gradient of the graph, which is gradient's another word for slope, and and c is the y-intercept. So c is the point at which the graph crosses the y-axis. All right, so I'll show you how you can get that later on. But yeah, let's take a look at gradient first. Okay, so I've got a graph over here. I didn't put in the numbers, but let's see. 0, -1, -2. So this graph crosses the x-axis at -2, and it crosses the y-axis at +1. Now, what would the formula be for this graph? Well, gradient is also known as the change in y over the change in x, or the change in y divided by the change in x. So let's see what the y value is here and what the y value is here, and then we'll work out one minus the other. It doesn't matter which way around you go, you are going to get the same answer as long as you go the y value here, the y value here, over the x value and the x value, or you go the y value over the y value, y value minus the y value, x value minus the x value. So as long as you use the points in the correct order, or the same order, you're going to get the same gradient. Okay, so I don't know, as a rule, maybe because I'm boring, I always work from left to right like I read. So what I've got over here is my y value over here is 0. So if I look at the y value, I'm reading what is y when it's here. So I read off the y-axis, and y is 0. So I've got 0 minus, and I go and look at what is my y value over here. It's crossing through 1, so it's 0 minus 1. At the bottom, I'm now going to look at my x values. So again, the same order. I did this point, then this point, and at the bottom, I'm going to do this point and then this point. So the x value here is where it crosses the x value. So that's -2, and the x value here is 0. So -2 minus 0. Right, so if I take a look, I've got -1 over -2, and we can cancel the negatives because a negative divided by a negative is a positive. So I end up with a half. So my gradient here in this graph is a half. So in other words, my equation for this is y equals a half x plus c. So we write the format of a graph in this y equals mx plus c format. Now c is where it crosses the y in the y-axis. So another way of thinking of it is, if we covered this up, I'm not able to do it now, but if we covered this up, that would be like, okay, let's say x is equal to 0, because x is equal to 0 anywhere along the y-axis, because x we read as 0, x we read as 0, we read that the x value is 0. So if we said, let's say this is 0, a half times 0 is a half, so then we would have y equals c, and that's why we know that where y equals c, that's the x-intercept, it's where it crosses, it's the y-intercept where it crosses the y-axis. So I already can see that it crosses the y-axis at 1. So my equation, or the formula for my straight line graph for this straight line graph is y equals a half x plus 1. And that's how we write it. So there we've gone from a graph to a formula for a graph. Okay, what about if we've got an axis, a graph like this? So I haven't put the arrows on the end, which I should have, but here we go. Let's see. Again, y is equal to the change in y over the change in x. I was just thinking I should probably go back and prove to you that it doesn't matter which order you do it in, but okay, let me do it. All right, so if I ignored this and I decided to go the other way around, so I decided to start with this one, this would be y is equal to 1, and this would be y is equal to 0. So then instead of 0 minus 1, I'd have 1 minus 0. If I look at the x value here, the x value is 0, and the x value here is minus 2. 0 minus 2 and 1. Sorry, I'm doing that the wrong way around. Maybe I should jump across the whiteboard and do it. Okay, let me go do that. Oh, it's my second lesson I'm filming today. My brain is tired. Too much maths in one day. All right, whiteboard. Right, and across to the whiteboard on my workings, and let's move so we are on our graph. I'm going to just simply change color and draw my same graph in there. Right, so ruler on. All right, so the graph I was looking at did this. No, it did this. All right, so I then have the formula for a graph that was y equals mx plus c. I'm going to look at m first. So m is equal to the change in y over the change in x. You don't need to, the triangle just means change, but I'm looking at the change in y over the change in x. So my value there, my xy coordinates is 0 and 1. Sorry, that's looks like I've said minus 1. 0 and 1. And my coordinates over here are my x is minus 2 and my y is 0. Right, so my change in y, if I start with this one, is 1 minus nothing. And my change in x is 0 minus 2. All right, so I'm behind my picture. All right, sliding it across a bit. All right, so I had change in x, change in y over change in x. I took a look over here and I said, well, 1 minus nothing, that's my y. And then I said 0 minus 2. All right, and if I simplify that out, I get 1 minus nothing is 1. And the minus times the minus ends up as a positive, which is a half, which is the same as what I had when I worked it out the other way around. As you can see over there, it gave me the same gradient, the half. All right, so careful that when you are subtracting with a negative number, you remember to multiply out that bracket so that you get the correct answer. Okay, so this one I was looking at, and we have to work out what is the gradient. So it's the change in y over the change in x. Right, so I started with the y value being 2. That's this point here. And then I'm subtracting 0, which is the y value level with there. And on the other side, I said, well, x is 0 over here. So x is 0 over there, and x is 1 over there. So 2 minus nothing is 2, and 0 minus 1 is minus 1. So I'm left with minus 2 over 1, all right, which is the same as minus 2, because anything divided by 1 is itself. Right, so my gradient then for this one is minus 2x, and if I can find my mouse pointer, you can see the y-intercept is 2, so it's plus 2. Now something to note is this negative sign is associated with a downward sloping graph, and a positive sign in front of the gradient is an upward sloping graph. So if you've got this, it's going to be a negative gradient. If you've got this, it's going to be a positive gradient. Okay, so let's find some equations, including looking at those oddities. And those oddities are y equals x, which looks a little bit weird. That is a graph. Y equals 4, and x equals 3. Right, let's cross over to the whiteboard. Okay, I am going to erase some of the things on here. So let's erase. Right, let's look at those funny ones first. The y equals x. Right. Now, y equals x is basically saying that any x coordinate you have on your graph is equal to its y. All right, so if y is 0, then x is 0 too. So that would be this point here. If y is equal to 1, x is equal to 1. Y is equal to 2, x is equal to 2, and likewise we head on down the other way. So the graph, the graph that I'm busy drawing here, where y is equal to x, is that line there. If I was faced with a situation of y equals minus x, then I'd be looking at this graph over here. Right. When I've got a situation like y equals 4, and in fact what I'm going to draw now is not y equals 4, I'm going to choose y equals 2. All right, what that's saying is that anywhere on my graph is 2. Right, so in actual fact, that is y equals mx plus 2, but the gradient is 0, so it's not going up. So 0 times anything is 0, which means that this term becomes nothing, and we're left with y equals 2. Right, now, as a graph, what that means is that anywhere along your graph, y is equal to 2. And in reality, that is a flat line. So there is no x-intercept. It doesn't cross the x-axis. Right. Now, for the other way around, if we've got a situation where, for example, I've got the ruler on still, x is equal to 3, it's the same situation, but it's a vertical line. So x is equal to 3 when it passes through 3 on the x-axis, which is that line over there. It also started off with the format, let's shift this over just a tiny bit, switching between ruler, not y, equals mx plus c. All right, but there is no y-intercept, so y equals mx. Right, and then we're going to go, no, I did that the wrong way around. No, that is the correct way. So then we're going to say, well, what is the value of x? It's always going to be 3. It wasn't a very good explanation, but it's the x is always 3. And if you put it into the formula, it does work. Right, so let's head over to some practice now, where we've got a graph drawn, and you are required to find the formula for the graph. So you've got to determine the graph's equation. All right, let's zoom in just a little. Okay, that's fine. Right, what do we know about this graph? We don't know anything other than it passes through the points that are shown there on the axis. So let's start off by writing down our formula. Y equals mx plus c. Okay, let's start with our gradient. M gradient is equal to change in y over change in x. Doesn't matter which way around we go. I'm going to work from left to right because that's how I prefer to work. Doesn't make a difference. Y equals, okay, so m equals the change in y. So I'm working from the point where y is equal to 0. So 0, this point is 0 minus, this point is minus 2, 0. And this point is 0, 4. Right, so remember, because it's the xy coordinate. So for my first, if I'm working from the left to the right, I'm looking at the y coordinate, so it's 0 minus 4, and at the bottom it is minus 2 minus 0. So then my gradient simplifies to minus 4 over minus 2, which is the same as, well, our negatives cancel each other out, and 4 over 2 simplifies to 2 over 1, which is the same as just saying 2, so our gradient is equal to 2. And popping over to the other side, I'm now going to put that into my formula. Y is equal to 2x plus c. So now I just need to identify the intercept with the y-axis. It passes through the y-axis at 4. So then my formula for this graph is y is equal to 2x plus 4. Okay, let's look at another one, and then we'll move on to something a little bit harder because it doesn't work quite as efficiently or nicely. All right. So again, over here, it's going nicely through the x and y coordinates at points I can see. So I'm going to start off with working out my gradient. M is equal to change in y over change in x. All right, I'm not going to write the m each time. So let's write down my points each time. This point on the left, the x value is 0 and the y value is 4. And this point down here, the x value is 2 and the y value is 0. So putting that into my formula, y goes from 4 to 0, so 4 minus 0, and x goes from 0 to 2, 0 minus 2. Right, simplifying, I end up with 4 over minus 2. Another way of writing that, if we simplify, is it's 2 over 1, and we've got a negative, so it is negative 2. So moving over to the other side, y is equal to minus 2x plus c. I can see that my y-intercept is at 4, so then my answer is y equals minus 2x plus 4. Okay. It's quite nice and easy when your graph goes through integers on the x-axis. Then it's quite nice and easy to see. But what if you're faced with a situation like this one? Now, I can see that that does go through the point on the y-axis, but it doesn't go through an integer on the x-axis. What am I going to do? Right, well, what I can see is that this point here on the graph is at point minus 1, minus 1. And this point here is at 0, 2. So as it happened, in the ones that we've been looking at in the past, we don't actually need the intercepts to be exactly on an integer. What we really need is any 2 points on the line. Because once you've got any 2 points on the line, you'll be able to work out the gradient of the line, and then as long as you can see, in fact, even if you can't see, you'll be able to work it out. But yeah, let's then say that as long as you've got 2 points, and we know these points have zeros in them, but they're still just points on a line, so we can work that out. Okay, so I don't know the point where it crosses this, but I do know that, and I do know that. All right, so let's go with our formula and see how far we get. So working out m first. It's change in y over change in x. All right, so this time, I'll still work from left to right. So my y goes minus 1 and 2. So then I've got minus 1, minus 2. And my x starts at minus 1, and then it gets to 0. So minus 1, minus 0. I'm left with minus 3 over minus 1, which is the same as, cancels out, 3. Right, so my gradient for this graph is 3. In fact, the bigger the number, the steeper the graph when you've got it like this. Or the smaller the fraction, the steeper the graph, the bigger the denominator, but that would be going down. All right, so on the other side, y equals mx plus c, y equals 3x plus c. What is my x-intercept? Well, my y-intercept, at this point, it happens nicely because it crosses at a specific value. So y equals 3x plus 2. And there's our answer. All right, so here is a nice example. All right, so I've got an example here where I have 2 points on the line. I don't know my x-intercept. I don't know my y-intercept. So I'm going to start off by finding the formula for the graph, and then from there, I'm going to try and find the x and y intercepts. But I think before we do that, it might just be time for a Nomu hot chocolate study break. Let's be honest, studying sucks. But here at Worksheet Cloud, we make it suck way less. In Worksheet Cloud, you can earn avatars, sidekicks, collectible coins, and then level up all while studying. Plus, we've just added our most exciting feature to date, the brand new Worksheet Cloud Rewards Hub. With Worksheet Cloud Rewards Hub, you can earn epic rewards and unlock entry tickets to win real giveaway prizes, including a Sony PlayStation 5, some yummy Nomu hot chocolate, and some fresh Worksheet Cloud merch. The more questions you answer, the more points you earn, and the more rewards you unlock. Worksheet Cloud makes your studying easier with video lessons, practice exams, practice questions, and study notes. In other words, we're your go-to place for all your studying. Ask your parents to sign you up at worksheetcloud.com today. And now, back to the maths. I've had so much hot chocolate during these lessons. It has been awesome. I feel a bit buzzed. Right, okay. Again, like I said before, for working out the gradient, it doesn't matter whether your points are on the x or y axes, as long as you have 2 points. Now in this case, they're not on the x and y axes. I can still work out my gradient. All right, so m equals change in y over change in x. I'm going to work from left to right. So I've got equals, so y goes from 3 to 1, over x goes from 3 to minus to 6. All right, which leaves me with 2 over minus 3, which is the same as minus 2 over 3. All right, I almost don't have enough space, but let me shift across here. Hope you can remember that it was minus 2 over 3 because I've now covered it. But y equals minus 2 over 3x plus c. So now comes the tough part. I don't know what my c value is because it's not in the picture. So how am I going to figure it out? Well, actually, it's not all that difficult because you just need to remember that when it crosses the y-axis, that is when x is equal to 0. And when it crosses the x-axis, that is when y is equal to 0. So let's start off to find the y-intercept. Let's let x equal 0 because it will be true that when x is 0, we know what the y-intercept is. All right, well, let's see. Okay, so then we would say y, just switched it off by touching it to my face. Y equals minus 2 over 3 times 0 plus c. Y equals c. Oh, that's not useful. Let's see if we can find the x-intercept. Right, so to find the x-intercept, we're going to let y equal 0. Right, so then we're saying 0 is equal to minus 2 over 3 x plus c. Right, and I'm being so silly about this. No. Okay, let's take that back a step. It's been a while since I did graphs. No excuse. All right, let's sub in the point 6, 1. So I know that the point 6, 1 is on my graph. So I'm going to let y equal 6, and I'm going to let x equal 6 and y equal 1 and see what my c spits out. All right, so in fact, I'm going to say 6 1. I'm going to color coordinate so that we can get this right. Okay, so y, no, we now said y is equal to 6. So 6, no, we said y is equal to 1. It's an xy coordinate. Equals minus 2 over 3 times, and now we want red, 6. That's just for subbing in. And then we had plus c. Okay, let's now solve this. Let's multiply out first. So we've still got a 1 equals, so minus 12 over, so what I'm doing is I'm saying 2 times 6 is 12. I can do this in one step, but I'm going to do it in two. So 12 minus 12 over 3 plus c. 1 equals, all right, so minus 4 plus c. Yeah, now I'm going to move this across to the other side, and I do that by adding 4 to both sides. So what I'm left with is 5 is equal to c. And now we know that our y-intercept, oh, come on, computer, catch up. Our y-intercept is therefore 5. So we first of all got the generalized formula, and then we substituted in a point that was on our line. So our final answer then for the gradient, or for this graph, is y equals minus 2 over 3x plus 5. There we are. That's how we get the gradient of graph, where we've just got 2 points. And so the next step is to go the other way. So that's where we start with an equation, and we need to draw the graph. Okay, so equation to graph. The easiest way is to find the intercepts is to find the y-intercept is where x equals 0, and to find the x-intercept is where y equals 0. So when you're given an equation, just put those in, and it'll tell you where it crosses the crosses the axes, and then you can do the working. So I've got, that was a very short trip to the slideshow. I have got some equations here, and we are going to draw these graphs. Probably not all of them. Let's just check how much time we have. All right, we were going for 31 minutes, so I think we'll probably have time for maybe 4, maybe 3. Right, so putting on my ruler so I can draw some nice graphs. Okay, I think let's take the first, the third, the fifth, and the 7th. We'll see from there. All right. Okay, I've got my xy coordinate. I'm going to use, my x and y axes, which should be labeled. So x, y. I'm going to use each of those light squares as a thing. So we're doing number 1, and our formula then is y equals 2x minus 4. All right, so I need to find out where it crosses the x and y axes. So I'm going to do my workings on the right here. So I'm going to start with my x-axis, x-intercept. Mathematicians are lazy, we just shorten things, so I'm not going to write out the whole intercept word. So to find the x-intercept, I'm going to let y equal 0. And I do that because where y is 0, that is when it will cross this line. Okay, so I'm going to put, I've got my equation, y equals 2x minus 4, and I'm going to let y equal 0. So in other words, I'm going to say 0 equals 2x minus 4. Next step, let's get rid of the 4. I don't know why I demonstrate this out loud, but I'm going to add 4 and add 4. So I'm left with 4 is equal to 2x, because those two then cancel each other out. I want to get rid of the 2, so I'm going to divide both sides by 2, which then gives me 2 is equal to x. So that means that the x-intercept is at x equals 2. All right, so that would be there if I'm using the little blocks. If I then want to find the y-intercept, I'm going to let x equal 0. So let's do that in a different color. All right, so y int let x equal 0, 0. So then I've got my formula, y equals 2x minus 4. Y equals 2 times 0 minus 4. Y equals minus 4. Right, so it crosses the y-axis at minus 4. Right, now that I've got my two lines on my, or two dots on my graph, I simply would use a ruler. I wonder if I should use a ruler. I probably should use a ruler. Okay, to join those 2 points. Now I should also go, it's just a little hard to get the same straight line, but this should go on in both directions and have arrows underneath it. Right, and there is the line, and you should label it y equals 2x minus 4. Now, good check to see the sign, right? My positive gradient, which means it's going up, which is correct, should put arrows on both ends, and there's our graph. Okay, we've done one. Let's do another. Wonder if it's, no. Okay, so our next one we're going to do is y is equal to, I'll move it down now, a half x minus 1. Okay, so we're going down here, so I can draw it. And x, y. Right, so to find our x-intercept, we're going to let y equal 0. So then we've got y equals a half x minus 1. 0 equals a half x minus 1. 1 equals a half x. All right, which is, it's because I added 1 to both sides, which is how I got it across. And then to get rid of the half, I've got a double. So 2 is equal to x. In other words, it crosses at 2. Right, which is there, the same point as the previous one. However, the gradient is different, and you'll see that in the angle of the graph. Right, to find our y-intercept, let's shift across. We are going to let x equal 0. Okay, so our formula was y equals a half x minus 1. We let, so y equals a half of 0 minus 1. Y equals minus 1, which means that we cross the x-axis over there. And if we're going to draw a line, our line is then going to be there. And good manners to label it. Y equals a half x minus 1. Okay, we've got 2 down. I said we would do 2 more. Let's double check the time. Yeah, we might do 1. No, we're going to do 2. All right. Our next one was 1, 3, 5. Okay, we've got a negative 1. Okay, so y equals, I'm writing it out of screen on my iPad, but I'll move it up now. Minus 2 minus a quarter x. All right, they wrote it in a different format, but it's going to work out the same. All right, so let's draw the lines first. All right, that's very lazy of me not to draw it further. Should do arrows on both ends. Okay, now to find the y-intercept, sorry, x-intercept first. You can do it either order. I've just done it this way around each time, so I'm going to do it the same. Let y equal 0. So our formula was y. Okay, now I'm going to rewrite this formula in the order that we've used before. So minus a quarter x plus 2. So I've simply changed those two terms around, and that's because I want it to be in the same order, but it will still spit out the right answer whether or not you change it. So naught equals minus a quarter x plus 2. I'm going to shift my x over to the other side because it's already a minus and I need it to be a plus. So when I shift it across, it becomes a quarter x equals 2. I need to multiply this by 4 to get it to be a whole x. So x, and if I do it to the left, I do it to the right, equals 8. Right, so my x, that's 5, 6, 7, 8, is going to cross over there. To get my y, I'm now going to let, so the y int, I'm going to let x equals 0. So y equals minus a quarter x plus 2, y equals 2. Right, so I'm crossing the y-axis at this point here. Now I just need to draw my straight line. If I can get the right one. There we go. And I haven't quite got it straight yet. There we go. Right, and there is our graph that we were drawing. So that is the line y equals minus a quarter x plus 2. Okay, last one. I'm going to go right ahead and draw it first because no, my ruler is not still on. All right, I hope I've got enough space here. Y and x. Okay, and this one, the fifth one was, okay, that was that. So no, now we're on the seventh. Y equals 1 minus half x. Y equals 1 minus a half x. Scrolling down. Okay, we've got it. Y equals 1 minus a half x. To find my x-intercept, I'm going to let y equal 0. So again, I'm going to just change the order I've written it. Minus a half x plus 1. Naught equals minus a half x plus 1. I'm going to shift the x across because it's negative and I want it to be positive. So half x is equal to 1. Double it, so it's just x is equal to 2. So this means it crosses the x-axis over there. My y-intercept, y-int, let x equal 0. 0, no, I've got to write down the line, the whole thing first. Y equals minus a half x plus 1. 0 equals minus a half, no, wrong way around. Y equals 1. So, 1 over there. All right, now I just need to draw a straight line that passes through it. So I'm going to, no, ruler. So 2 up and 1 down, 1 down. There we go. And my equation is y equals minus a half x plus 1. All right, that's how we do it. So practice is what's going to make it, right? You've got to be able to go both ways. You've got to be able to go from the graph. You've got to see a graph and be able to make it into an equation or find the equation for a line. And you've also got to be able to take an equation and convert it in or draw a graph from the equation. Only way you're going to get that right is to practice it. So click on the link in the description below this video to download your free worksheet and memo so you can practice what we've been doing or what I've been doing, or hopefully you've been doing as well, by pausing the video so that you can practice it and get good at it. And of course, you can practice some more at school this term as well. In closing, I remind you, if you're not yet part of the Worksheet Cloud crowd, then you should get your parents to head on over there and sign you up. There are lots of benefits to it, not just in maths, but in all of your subjects. There's a lot of great content on there which will help you practice. There's memos for you that can check your answers, so you don't have to wait weeks or days or forever for your teacher to actually mark your work. I know how it is for teachers as well, because you've got a lot to do. But yeah, at Worksheet Cloud, you can see the memo straight away. And you can earn cool rewards, such as the Nomu hot chocolate, the Worksheet Cloud merchandise, or possibly even that PlayStation 5, which would be awesome. Grade 9s, it's been real. Good luck with the rest of your studies this year, and goodbye.